in the previous lecture we have looked at functions which are periodic with a period 2 pi, right? So but what about those functions which are also periodic but the period is different from 2 pi? So we'll look at those kinds of functions today. When f of x is periodic, right, and the function is represented between minus pi and pi, so the period is 2 pi. Okay, we have a naught. Let's write the Fourier series first. So we have f of x can be represented as a Fourier series, which is a naught by 2 plus a1 cos x plus a2 cos 2x plus b1 sin x plus b2 sin 2x and so on. Okay, so a naught is given by 1 by pi integration from minus pi to pi f of x dx. An is given by cos nx dx, and bn is given by 1 by pi integration from minus pi to pi f of x sin nx dx. Okay, but if the function is represented from 0 to 2 pi, right? So period is still 2 pi, but the function is represented from 0 to 2 pi. In that case also, then again a naught will be same as 1 by pi, but now the limits of integration will go from 0 to 2 pi f of x dx. An will be 1 by pi 0 to 2 pi f of x cos nx dx, and bn will be 1 by pi 0 to 2 pi f of x sin nx dx. And if we are looking at Cn in the for exponential Fourier series, then this will be represented by 1 by 2 pi 0 to 2 pi f of x e power minus I nx dx. Okay, so this is when the period is 2 pi. But what happens if the period is not 2 pi? Okay, so if the period is different from 2 pi, okay, let's say the period is 2L. 2L. So maybe the function is represented from minus L to L or 0 to 2L. Okay, for in both of these cases, period is 2L, right? Okay. So after 2L, in this case after 2L, the function will repeat its pattern. In this case after L, the function will repeat the pattern. Okay. So in both these cases period is 2L. So we need to find a function. So we need to find a sine and cos function which is periodic in 2L. So what is that function? So that function, so a function which is periodic with period 2L is nothing but sine n pi x by L. Why am I saying that this is the periodic function? It's because we can verify it. So let's say we add, okay, we add some 2L to this, and then we have to see whether it is periodic or not. So for x, so in x if we add 2L, what will happen? So let's verify. So what we are doing is we have sine n pi by L into x plus 2L. So this is our function. So we are basically adding 2L to x. So this is nothing but sine n pi x by L plus n 2n pi, right? So if you just multiply this with this term, you will get 2n pi. So any function, right, after 2n pi, so after n number of completing the circles, the sine function is going to be the same. So this is nothing but sine n pi x by L, right? Because if x is 30 degree, right, then sine of x plus 2 pi is also same as sine x, right? Sine of x plus 4 pi is also same as sine x, right? So every 2 pi means it completes one circle. So after one circle, it is the same as your original sine function, or even for cos function. So this is essentially, so this function is periodic with period 2L. Okay. So how can we write the Fourier series? So f of x, if f of x is a periodic function with period 2L, then f of x can be written as a0 by 2 plus a1 cos n pi x by L plus a1 cos pi x by L, right? Because n is 1 for this part. And then here you have cos 2 pi x by L and so on, plus b1 sin pi x by L plus b2 sin 2 pi x by L and so on. Okay. Alright. So this can also be written in the, you can simplify the writing of this function using the summation. So you have n equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Okay, so this is your f of x. In exponential representation, right, in exponential representation it will be represented as f of x is equal to minus infinity to infinity cn e power minus I n pi x by L. Okay, so this is how you would do it. So again here we have the coefficients a0, a1, right? a0, a1, a2, b1, b2, etc. So we need to find them. So you can use the same procedure and verify it. But the basic idea is the coefficients will be given by 1 by L integral from minus L to L f of x dx. This is your a0. an is 1 by L minus L to L f of x cos n pi x by L into dx. bn is 1 by L integral from minus L to L f of x sin n pi x by L dx. And Cn, for exponential Fourier series you would need Cn. So Cn is 1 by 2L integration from minus L to L f of x e power minus I n pi x by L dx. Okay. So this is going to be your the formula for the coefficients. Of course, if the function if f of x is represented between 0 to 2l, right? So with period 2l, then again, right, so f of x would be represented by the same kind of formula, which is a naught by 2 summation n equal to 1 to infinity an cos n pi x by l plus bn sin n pi x by l, or f of x will be Cn e power minus I n pi x by L. So this series will be the same. Only thing is that the formula will change a little bit. So instead of integration going from minus L to L, the integration will go from 0 to L. So A naught will be 1 by L 0 to 2L f of x dx. A1 is 1 by L 0 to 2L f of x cos an cos n pi x by L dx. Bn is 1 by L 0 to 2L f of x sin n pi x by L dx. Cn is 1 by 2L, so there is a difference, right? So Cn has 1 by 2L 0 to 2L f of x e power minus I n pi x by L dx. Okay, so this is going to be your formulas for all of this. So now let's do a problem. Okay, so f of x is given by 0 between x and L, between 0 and L, and 1 for x between L and 2L. Okay, so we want to find, so represent f of x in terms of Fourier series. Okay, so let's do it in terms of exponential Fourier series. Okay, so we need to only find Cn, right? So what is f of x? F of x is nothing but n equal to minus infinity to infinity Cn e power minus I n pi x by L. Okay, so what is Cn? Cn is nothing but 1 by 2L 0 to 2L, right? Because the function goes from 0 to 2L. Okay, that's why I have taken it limits of integration to be 0 to 2L. Okay, f of x e power minus I n pi x so there was a mistake here, right? So this is going to be, so this is plus, and I think here also this is fine, this has to be plus. Okay, so f of x when it's written in terms of the Fourier series, for exponential Fourier series, it is Cn e power plus I n pi x by L, but in the formula it is to calculate Cn, the formula has e power minus I n pi x by L. Okay, so please be careful about that, otherwise you will make the same mistake that I made. Okay, so this is our, so now f of x took the value 0 between 0 and L, between 0 and L, and f of x took the value 1 when x was between L and 2L. So we will have into dx. So this term is obviously 0 and only this term is left. So you see there was a problem here. So this is nothing but L. This is also L. So it goes from L to 2L, right? Alright. So this will be e power minus I n pi L by L. Okay. So we are going to get minus 1 by 2n pi I e power minus I 2n pi e power minus I n pi. Okay. Alright. So let's look at this. So e power minus I 2n pi would be cos 2n pi minus I sine 2n pi minus cos n pi minus I sine n pi. Okay, so sine n pi and sine 2n pi are both going to be 0. Alright, this we already know whether n is odd or even. So we are left with by 2n pi I cos 2n pi, right? Cos 2n pi minus cos n pi. Okay, so now let's look at when n is even or odd. So when n is even, this term would be when n is even, you would have cos 2n pi would also be 1 and cos n pi would also be 1. So 1 minus 1 is even. And when n is odd, you would have cos 2n pi would be 1 but cos n pi would be minus 1. So when n is odd. So this is going to be so obviously this is going to be 0, 0 when n is even and 1 by n pi I when n is odd. Okay, minus 1 by n pi I when n is odd. Alright, and what about when for C naught? For C naught is given by 1 by 2L 0 to 2L f of x dx, right? So this is going to be 1 by 2L L 0 to L 0 dx plus 1 by 2L L to 2L 1 dx. So this is 0 and this is going to be half. Okay, so this is going to be half. So your f of x becomes half and for n is even you have 0, when n is odd you have this term. So you can verify this, right? So 1 minus, so this is an exponential function, right? So you would have to write it as e power I pi x by L plus 1 by 3 e power 3I pi x by L and so on. Minus 1 by pi I into e power minus I pi x by L plus 1 by 3 e power minus 3I pi x by L and so on. So there is a minus because it is a minus 1 by n pi I. So n is either plus or minus. Okay. Alright. So this is going to be your f of x. So if a function, now let's look at if we can simplify Fourier series if function is even or odd. If a function is even or odd. So first if so when is a function even? So even function is when f of minus x is equal to f of x. An odd function and f of minus x is equal to minus f of x. Okay. So and then again sine x is an odd function, right, because sine of minus x is equal to sine minus sine of x, and cos x is an even function since cos of minus x is equal to cos x. Okay. Alright. Now if you multiply, if f of x is odd, then f of x sine x becomes an even function, right, because this is odd and odd, so multiplying two odd functions you get an even function. And f of x cos x remains an odd function. It is an odd function because you are multiplying odd and even together, and here it is odd. Okay, so if you multiply odd and even together, then you have an odd function. If f of x is even, then f of x sine x would be an odd function and f of x cos x would be an even function. Now you know the logic why they are odd and even. Okay, so now let's see. So now if f of x is odd, right, then Vn would be 2 by L, 0 to L. So let's write it down properly. So the actual formula is minus L to plus L f of x sine n pi x by L, right, dx. And then if f of x is odd, because this becomes an even function, so you can write 2 by L, 0 to L f of x sine n pi x by L dx, and an will become similarly 1 by L minus L to L f of x cos n pi x by L dx. So this is an odd function, So this becomes 0, because if you go from minus L to L of an odd function, you are going to get 0. Okay. Similarly, if f of x is even, then you get bn is 0 and an is 2 by L 0 to L f of x cos n pi x by L dx. Okay. So this way you can simplify some of the integration, so you don't have to compute all the integrations. Alright, so now let's give you a homework problem. Given f of x is equal to sine n pi x, where between minus half less than x less than half. Okay, given f of x is this, expand f of x in a sine cosine Fourier series. And second homework problem is if f of x is equal to a naught by 2, which is also equal to n equal to minus infinity to infinity cn e power in x, use Euler's formula to find an and bn in terms of cn and c minus n. Okay, so this is what you have to